Hello guys, in this video I'm going to introduce you to this fascinating research about the large language models and the data engineering practices. This paper is about G models of family, which is a collection of language and multimodal models with impressive multidimensional capabilities. They are rooted in both 6 billion and 34 billion pre-trained language models. These models are expanded into chat models, models that handle 200K long context depth enhanced models, and also the models that integrate vision and language. The base model of the G family exhibit robust performance across numerous benchmarks, including MMLU and the chat models. Once fine-tuned, they show a high human preference rate on evaluation platforms like Alpaca Eval and also Chatbot Arena. And this is the few of the comparison on these benchmarks. The success of the G model is attributed to their scalable supercomputing infrastructure and the utilization of classical transformer architecture with a significant emphasis on the quality of data achieved through meticulous data engineering. For pre-training, they have compiled 3.1 trillion tokens from English and Chinese text refined through a rigorous deduplication and quality control process. And you can learn about this technique more in the paper, and I will drop the link in video's description. Now, in the fine-tuning phase, they have meticulously refined a smaller set of infrastructure under just 10K through multiple rounds of reviews, ensuring each instance is validated by their machine learning experts. In creating vision language models, they have merged the chat models with a vision transformer encoding and enabling the model to watch visual elements with the language model semantic field. They've also managed to extend the model's context handling ability to 200K tokens through continued lightweight retraining, enhancing its ability to efficiently sift through vast amounts of data. The strategy of extending the depth of pre-trained models through ongoing pre-training has further elevated the model's capabilities. Now, if you go through this paper, this is really a gem of information as how to train and fine-tune strong models. And these days, where most models really refuse to publish any meaningful information in the paper, I think this paper contains a lot of information as especially around data as how the data was collated, filtered, and then the data mix, etc., and how the SFT data was processed. I have gone through this, and then there are a few nuggets which I think are worth mentioning. For example, when it comes to the sequence parallelism or data engineering side of things, the training, they have done some wonderful things. For example, I believe that they have hooked up their node in a ring topology, and then each node holds a chunk, and from there they have done some partial attention score, and then they have did some sort of ring attention in this case that do not do the partial softmax and the fused MLP in the same round. Now, my main interest for this paper was around data engineering because they have shared a lot of good details there. So, for example, if you read through these pages from the paper, it has some really useful information. For example, for the data engineering for the long context, to adapt the base model to longer context, they have continued pre-training the model on 10 billion tokens from their pre-training data mixture with slightly unsampled long sequences, mostly from the book. They have also observed that only 1 to 2 billion tokens are enough for the model to converge to low loss on 4K to 200K length, and a lightweight fine tuning further induces near perfect long context retrieval performance. Based on this information, they have tend to view that the capability of modeling longer dependency than the pre-training length is an intrinsic capability rather than being injected by the post-train. And this has lot of implication. For example, I think The long context capability is latent in the model and just need to be teased out with some continued training on longer sequences and specific long sequence tasks. So it seems that now we don't really have to worry about huge data set. If we have a very high quality smaller data set like under 30 billion or something like that, we are good to go, because it seems that now people have realized that the value of high quality smaller data set is really good, and that they won't be as large anymore unless you're trying to fully retrain or go super deep into expert mode fine tuning. So I think that, as if we just say about dataset in short, that 10K carefully curated training examples are plenty enough for a good general purpose chat fine tune. That's it. Let me know your thoughts on it. I think a really groundbreaking effort on the part of these researchers. As I said, I will drop the link in video's description. Go through it. Let me know what do you think. And if you like the content, then please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps. Thanks for watching.